Hi everyone, welcome to this topic. Today we are gonna talk about the fatty acids. Fatty acid oxidation is also called as beta oxidation of the fatty acids. The fatty acids are the major energy source that give approximately 9 calories per gram, and the fatty acids in the body that are mostly oxidized by beta oxidation. Beta oxidation might be defined as the oxidation of fatty acids on the beta carbon atom. So now let's see what a fatty acid looks like in its simplest form. Fatty acid have a carboxylic acid group with a long chain of carbons hanging down of it. This arrow represents any amount of extra carbons that could be hanging off the carboxylic acid. So those fatty acids come from the fats in our diet, and they are a great source of energy. You will see why in a moment, but first of all, they need activation and transporting into the mitochondria. The first step is to add adenosine to the fatty acid. This creates an acyl adenolate. The adenosine comes from adenosine triphosphate or ATP, and we get rid of pyrophosphate in the process. Using the high energy ATP in this process, charge up the molecule for the next transformation. With the help from an enzyme, this molecule now becomes an acyl-CoA. A coenzyme A is required for the reaction and it replaces the adenolate, which now gets kicked out. The enzyme that orchestrates all this is acetyl-CoA synthesase. The acyl-CoA gets a carnitine attached, and the coenzyme A pulled off. Therefore, it becomes an acyl-carnitine. The coenzyme A gets recycled, and obviously, a carnitine molecule is needed for this process. The enzyme who does this is carnitine acyltransferase 1, and it's located in the outer mitochondrial membrane.
Now here we have the inner mitochondrial membrane, and stuck in its transfer protein which allow the acyl-carnitine to pass through. This now means the acyl-carnitine. Within the inner mitochondrial membrane, a coenzyme, a molecule, now gets reattached and carnitine pull off, and this recreates our acyl-CoA. The only difference is that time the acyl-CoA with the inner mitochondrial membrane. The enzyme that does all this carnitine acyl transfers to the carnitine, then gets shuttled back across the membrane to continue this process. Now that acetyl-CoA is located with the mitochondria, beta oxidation proper can occur with the process. Has 4 phases. In the first, the acyl-CoA is dehydrogenated to form a trans delta 2 enoyl-CoA. In this process, FAD plus is reduced and becomes the higher energy molecule, FADH2. These FADH2 molecules can be used in the electron transport chain. In this area, the enzyme that oversees the reaction is individually named acyl-CoA dehydrogenase. This process is an oxidation reaction. This is because FAD is an oxidizing agent, therefore it oxidizes the acyl-CoA molecule, and the end result is that now new double bond is formed between the second and the third carbon in the molecules. This is known in fatty acid nomenclature as double bond between the alpha and beta carbons. Moving along these molecules with its new double bond, get water added across double bond forming an L-beta hydroxy acid CoA. The enzyme involved here is called enoyl-CoA hydrates because the water is added. We call this process hydration. The end result is that we get a brand new hydroxy group on our beta carbon.
The third step in beta oxidation is the dehydrogenation of this new hydroxy group. To do this, NAD plus is reduced to the high energy NADH, which will also be used in the electron transport chain. Enzyme here is beta hydroxy acyl-CoA dehydrogenase, and the overall process is another oxidation reaction. So note that we have a new carboxyl group on our beta carbon. The next step is pyrolysis, which cuts off molecule through here. If you're paying close attention, you may notice that everything to the left of this dashed line looks like an acetyl-CoA molecule. And cutting it loose indeed gives us a brand new acetyl-CoA molecule. Now all we have to do is whack a new coenzyme A molecule on the end of the stuff to the right of the dashed line where we have an acetyl-CoA ready to go around this circle again, but this time with 2 fewer carbons, and the enzyme that does all this is called thiolase, and this process therefore is called pyrolysis. Now just put a reminder up here that every time the molecule goes around the circle, it has 2 fewer carbons. The molecule will keep going around the circle until there are no more carbons left to recap the acetyl-CoA. The acetyl-CoA has 2 carbons removed from it in the form of acetyl-CoA. Every time it goes around the circle, this happens until there are no carbons left, which is good unless there is an odd amount of carbons left in the fatty acid, or it has double bonds where you don't want them to be. To deal with this, a reductase gets rid of unwanted double bonds and odd number of fatty acids are sent through this circle until there are 3 carbons long. Then they get sent through a series of 3 reactions which turn them into succylcholine that also enter the TCA circle. Finally, the acetyl-CoAs which have been created can then head off to the TCA circle, which is also known as the Krebs circle, for even more energy production. So you can see that a 16 carbon fatty acid like palmitic acid can create quite a lot of energy, as it creates 8 acetyl-CoAs from the TCA circle. Compare that with the 2 that a glucose molecule creates. This is part of the reason that fats are so energy dense. And I hope with this few information you've enjoyed this topic. Thank you for watching, and bye.